Have you ever actually stopped to think about what's inside the batteries that power pretty much everything in our lives? We're going to go inside the high-tech factories that create these things to answer one big question. How is a battery actually born? We'll see how it goes from just a pile of powder to the powerhouse inside your phone and your car.
So here's a good one for you. What do your smartphone and an electric car really have in common? I mean, beyond the obvious stuff. What's the one piece of tech that truly connects these completely revolutionary devices?
Yep, you guessed it, the battery. But it's so much more than just a box that holds a charge. It is a genuine marvel of chemical engineering shrunk down and perfected to fit into our world. So come on, let's peel back the layers. Okay, so to understand how you build one first, you need the blueprint, right? We've got to know what the fundamental pieces are that make all this electrochemical magic happen in the first place. Okay, let's meet the key players. Inside every single lithium-ion battery, you've basically got these 5 main characters. There's the anode, that's the negative side, and the cathode, the positive side. In between them, you have the separator, the super important barrier that keeps them from touching. That would be very bad. The whole thing is soaked in the electrolyte, which you can think of as a liquid highway for charged particles. And finally, you've got the current collectors, which are basically just metal foils that let the electricity flow out. But there's one more character we need to talk about. It's kind of the unsung hero of the whole operation. It's called the solid electrolyte interface, or SEI for short. Now, here's the weird part. It doesn't even exist when the battery is first built. It's a microscopic little protective layer that forms later on, and it is absolutely vital for the battery's health and long life. Keep that one in the back of your mind. We are definitely coming back to it. All right, blueprint in hand, let's head out onto the factory floor. This is where the magic really happens, where raw materials, and I mean literally fine powders, get transformed into a high-precision power source. You know, the best way to think of this is like baking a very, very advanced cake. First, all the active materials are mixed into this perfectly uniform paste, which they call a slurry. This goo is then coated onto those metal foils with just unbelievable precision. We're talking about a layer thinner than a human hair. These huge coated sheets then travel through these massive industrial ovens to dry out. Then they get pressed by giant rollers, a process called calendaring, to get the density just right. And finally, these massive rolls are slit into the smaller electrode strips that'll go into each battery cell.
So now we've got our finished electrodes, kind of like the bread for our battery. It's time to assemble the perfect sandwich, which is really the heart of the cell.
And what's really interesting here is that engineers have 2 main ways of doing this. For those cylindrical cells, the ones that look like a normal AA battery, they create what they call a jelly roll by just tightly winding the anode, the separator, and the cathode all together. But for the flat batteries you find in your phone or in an EV, it's more like a deck of cards, with all the layers precisely stacked one on top of the other. With that sandwich all put together and placed in its can or pouch, it's time for the last few critical steps. The electrolyte, remember, that's our ion highway, is injected under a vacuum. They do that to make sure there are absolutely no air bubbles or impurities. Then the cell is permanently sealed, locking everything tightly inside. Now, at this point, you have something that looks like a battery, feels like a battery, but it isn't one. Not yet. It has no usable power. To actually bring it to life, it has to go through its very first and by far its most important charge cycle. This process is called formation. And here's the kicker. It only happens once. This one single charge cycle is the moment that defines the battery's entire future, its performance, its lifespan, its safety. You could say it is the single most important moment in a battery's life. No pressure, right? And this is why. This is where our unsung hero is finally born. That very first charge kicks off a chemical reaction that creates the solid electrolyte interface, the SEI layer. This microscopic film forms on the anode, and it acts like a protective shield, locking in the battery's performance for good. It's the final, absolutely vital step to create a stable, long-lasting power source. So, our single cell is now alive and ready to get to work. But the journey isn't over yet, not by a long shot. For the really big jobs, one cell is just a single brick. Now it's time to build the powerhouse. It seems kind of obvious when you say it out loud, but it's a huge engineering challenge. The power you can get from one single cell is tiny compared to what you need to get an entire electric vehicle moving. So you have to combine them into a much, much larger and more intelligent system. And this shows you exactly how they do it. It's actually a pretty brilliant, almost Lego-like approach. You take the individual cells and you group them together into what's called a module. Then you take a bunch of those modules, combine them with a lot of other smart hardware, and you create the final battery pack. So a modern EV battery pack isn't just a box of batteries. Yeah, it has thousands of cells inside, but it's also a really smart system. It has a brain called the Battery Management System, or BMS, that's constantly monitoring the health of every single cell. It has a complex cooling system to manage temperature, and it's all wrapped up in a super tough protective casing.
And to really complete the story, the cycle doesn't just end there. Today, advanced recycling technologies can break down old batteries to recover those super valuable materials. We're talking lithium, cobalt, nickel, so they can be used all over again to create the next generation of power. So, from a simple powder to a complex, intelligent system, making a battery is really a symphony of different fields. It's chemistry, it's material science, it's robotics, and it's precision engineering, all working together in perfect harmony to power our electrified future.
This incredible, intricate process is the foundation of the technology we have today. But it leaves us with one final, really exciting question. As our world demands more and more power, how are we going to engineer the batteries that will power tomorrow?